Hi guys, today we're going to talk about the real number chart. So when we're talking about real numbers, the one side is going to be reals. The other side is going to be imaginary. We're not going to spend time with imaginary numbers this year, but if you continue with College Algebra 2 or further math courses, you will experience imaginary numbers. The real number category breaks down into rational and irrational. Under rational, we have a few categories. So the first subset of rational numbers is going to be integers, then whole numbers, and then counting numbers. So one of the biggest things we're going to do is we're going to pay attention to the different categories of rational versus irrational. So the biggest thing for rational is it can always be expressed as a fraction. So if you can hit math fraction on your calculator, it's rational. They're decimals that end or repeat. The square root of perfect squares. So perfect squares are numbers that you can multiply by themselves. So if we're creating perfect squares, we would go with 1, 4, 9, 16, etc. So any number that we take the square root of, like that, is a perfect square. Square root of 9 is 3, the square root of 16 is 4, etc. If we're looking at irrational, irrational numbers are decimals that never end. So non-repeating decimals. That never end. Decimals with a pattern. Our famous decimal that never ends and does not repeat is pi, and then the square root of non-perfect squares. We'll do some examples in a moment. So integers, for example, integers are whole numbers and their opposites. So maybe -3, -2, -1, 0, 1, 2, etc. These go on forever. Whole numbers start with 0 and they go up. In counting numbers, the first number we count with is 1. So 1, 2, 3. Another name for counting numbers is natural numbers. So you might also see it referred to as natural. Let's look at some examples for rational and irrational. So if we have the square root of 7, is it a perfect square or not a perfect square? It's not a perfect square. If you type it into your calculator, it's very ugly, so it's irrational. 0.125. If I hit math fraction, it's going to change it to 1/8. So it can be expressed as a fraction or it's a decimal that ends. That'd be rational. 0.3 repeating could look like this. Again, you can type in a whole bunch of 0.3s. It can change to a fraction of 1/3. It's rational. 0.1, 1, 2, 1, 2, 3, 1, 2, 3, 4. That's a pattern. So patterns fall under irrational. Anything with a pi in it is going to be irrational. So if I give you pi over 3, that'd be irrational. Those are some examples, and you can try the other section of practice now. Thank you so much.